So, for starters, we need to answer questions if there are any on 2.2 and 2.3. So that means I taught that so well.
Taught it really good.
Is that what it was, Barker?
Yeah.
I appreciate that. Anybody else? Now, one person has a question on that.
Emma has a question that I have.
I did have a question that I asked Boston.
Yeah.
So, like,
You got me a number?
I don't, but I have like an example of what kind of problem it is.
That's if you got an example, I would love to do that. It is 9:24 today. 9:24, and this is going to be questions 2.2 and 2.3. What do you got for me?
So if you had like a problem that was parentheses, like 3x to the power of 2, y, and then the parentheses was to the power of 2,
Okay.
and you're distributing,
I'm going to go.
is the 3 its own?
Yes.
So it's
Okay.
separate?
Yeah, so it's like this. You want to think 3 to the first, x squared, y to the first, right? So that's all squared. I'm just going to take that to that one, and that one. And because I still have power to a power, what am I going to do here? I'm going to multiply, and that's going to give me, 2 times 1 is going to give me 3 squared. 2 times 2 is x to the 4th. 1 times 2 is y squared. But then I have to do what? Yeah, I got to do that math, right? And don't say 6. And we get 9 x to the 4th y squared like that. Is that?
Thank you, yeah.
Yeah? Okay. Alrighty, you had your chance, I guess. Alrighty, so on to 2.4 and 2.5. Alrighty. Same thing as last time. We are going to teach 2.4 and 2.5 together because, to be honest, they're like the same assignment. I'm guessing that, and I don't remember because this was not my packet to do, but if we were regular students, I could see how this could be done in 2 days, but we're not regular people, right? I'm special. That's what my mom told me. Nobody else has one of those moms?
I don't think that was
My dad said that.
Your dad said, okay, I could see that. Your mom's a realist.
No, she just says I'm cute, and then my dad says that I'm just special.
Okay, well, that could be. What did you say?
I said that's probably not good.
Why not?
Your mom calls you special. Special is a good thing.
Well, yeah, I'm a special person. I didn't say I was special, that kind of special. I'm just normal special. Yeah. I'm not sure what normal special is, but however you want to look at that. Yeah. I'm short guy, big mouth, gray goatee. His name's Mason. This was Mason. This was Dallin. Only like 3 of you know what I'm talking about, but whatever. Alrighty, so SM2H, my oldest boy's was Dallin. He gave me this gray. My youngest boy was Mason. He gave me this gray. Clearly his is more. Just saying. Because he was special. Alright, so we're going to do unit 2.4 and 2.5 today. And our objective is going to be able to, probably didn't see that coming, properly simplify expressions. Not using, sorry. That needs to be involving. Sorry about that. Involving radicals. Okay? Now, when I use the term radical, okay, it can be a slang term like that from the 70s. That might have been more 80s, right? Radical dude. Or I could be like the radicals of today, which we got a lot of them out there. But when I use the term radical, does anybody know what I mean? Yo.
It's like the square root.
It's like the square root. We're talking about the root. Now, it's not just square root, but it is the root symbol. Because it could be cube root, or it could be fourth root, or fifth root, or seventh root, or whatever, right? We will stay probably mainly between 2 and 4, you know. Now, if I were to say, let's say I went the square root of, I don't know, let's say the square root of 81. Okay? Now, most of you are just going to say that's automatically what? 9. Okay? But I want to show you how we're going to do this to make it so we can do any problem we run into. Okay? So what I want to do is I want to say, well, what is 81 really? It is 9 times 9, right? Well, is there another way I could write 9 times 9? Just 9 times 9 is 9 to the second, right? So I really have the square root of 9 squared. Now, this right here is the radical symbol. Then I've got something right here. Does anybody know what that number right there is called? Actually, it has a name. We don't have one. If it's not there, it's automatically a 2, right? But does anybody know what it's called? It's what's called the index number. Okay? It's called the index number. And then inside here, all this stuff, that is what is called the radicand. Yeah, not the radicant, the radicand. Okay? Now, what we're doing is we want the exponent on the inside of my radical and my index number to match. Once I do, I can go whoop, and I can pull that out. Okay? So now that comes out. When that comes out, that index number and that exponent basically reduce out, and I'm going to end up with a 9. But really, it's kind of like when I factor something out, what's left in here? A 1. So it's 9 square roots of 1. Well, what's the square root of 1? Just 1, so it doesn't matter, so my answer just ends up being 9. Now, when that's a number, it's easy. Okay, but watch. What if I have, let's do this. Let's see how smart we are. Okay. Now, did you just say you give up already? That's like the second problem. You can't give up already. That's like saying, hey, we're going to go on a hike. You take one step out of the car and go, I'm done. I'll just sit here and... Okay, that's not 2 to the 7th. Sorry, that's supposed to be... No, that's 27. It looked like 2 to the 7th. I don't know why that was. Now, what you want to do is you want to turn everything under the radical into something what? Squared, right? So what is 27? Okay, it's 3 to the 3rd. That is true. Let's write it 3 times 9 though, right? And then 9 is 3 times 3, and that's how I get 3 to the 3rd, right? But I don't want to write it that way. Anybody know another way I could write 3 to the 3rd to make it so I could whoop this? Nobody? Yeah, isn't it just 3 squared times 3? Now, why would it be better to write it like this? Let me write that 3 a little bit bigger. Nobody? Well, what number is it? What's my index number? 2. What's it going to allow that 3 to do? It's going to go whoop right out front. Okay? Now, that's my 27. Now, how can I rewrite x to the 5th? Couldn't I go x squared times x squared times x? Yeah. Now, why do I do it that way? Because now both of those can go whoop out front, right? And then what about y? Just stay y squared. What about z?
X squared times x. Z squared times z.
Yeah, z squared times z. You went x again. Okay. Now, this is what I do. I say everything that is squared can now go whoop and come out front. So I go whoop. And I go whoop, and I go whoop, and I go whoop, and I go whoop. Now, you laugh. You're going to get to your next class, your next math class next year, and you're going to do that. And your teacher's going to look right at you and go, you had Mr. Denton last year. And it's okay. Now, what am I going to have out front when I'm done here? I got that 3, right? Because remember, the 2 and the 2, they reduce out. And now do I have 2 x's? X squared. Because when they come out front, they're still timesing. X times x is going to give me x squared, right? And then I'm going to have y and then a z. Now I have stuff left. What's left inside?
3x z.
Just like that. Were you clapping like, ooh, good job, good job? Is it, or did you understand it?
I got it.
Oh, good. Okay.
Why can they go in the front? They have to be to the power.
They have to be to the same. The index number and the exponent must be the same. Once they are the same, they can come out front.
How do you know what the index is? It's 2.
It's 2 when there's nothing there.
When there's not one, it's automatically a 2. If it's not, they'll have a 3 or a 4 or whatever. Christian,
So is it 2? Why do you need to split it up in 2s? Because I might confuse with that part.
say that again.
So like the 2?
Yeah, because I knew this was a 2, which is why I made all these 2s. If that was a 3, I would have tried to have made all these 3s. You see what I'm saying?
Yeah.
You put it, you make it whatever you need it to be able to simplify the problem. Does that make sense?
And that's just the rule. It has to be that number. The index number has to match with all the exponents.
If you want to be able to bring it out front, yes, that is the rule. Because that is... What'd you say?
I said if you want to loop it.
Yeah, that was good. That was good. Yeah, good job. Okay, I want to be able to whoop it, which in...
Mr. Denton, back on that one, please put it back. When you whooped the 3 squared and you put it out in the front, why is it just a 3 now?
Anybody want to step?
You get rid of the X.
Because remember, that and that, once they match, they reduce out, so it's just whatever's left.
Okay.
Okay?
Thank you.
Why is it always 2?
Because that's what number's right here. It's whatever that number is. If that number was a 3, I would have made them all 3s.
Okay, but why?
Why is that always
Because it
Because that's what the problem told me to do.
Yeah, who made it so it has to be 2?
Yeah, but why when there's nothing
That's what the square root.
Okay, because that's by definition. Okay, so I see your question. By definition, if there is not a number out in front, it's always a 2. It's just like if I say X, it's really not just X, it was really what? It was 1X, wasn't it? We just never write that 1 down, right? Well, if I write a radical and I don't put a number there, by default it is a 2. Does that make sense now?
Yeah.
Okay. Anybody else? Nobody? Well, let's do another one. So let's say, you know what? Let's do this. So I have the cube root of 1. So it's a cube root now. Cube root of 135 x to the 5th. Now, whatever's inside, I want to have to be to the third power, right? So I got to try to break this stuff down and see if I can get something to the third, right? Well, what is 135?
5 times 27.
5 times 27, right?
Then 27 is 9 to the 3rd.
9 to the third?
No, 9 times 3.
9 times 3, and then 9 is?
3 times 3.
Who knows what I'm doing right here?
Oh, what's it called?
Factor
Factor tree.
Factor tree, David said. Factor tree, right? Okay, so now, how am I going to write that to make it so it suits me? What do I need it to be? Is it Hadley?
Yes.
Okay.
5 times 3 to the 3rd.
5 times 3 to the third. Now, why does that benefit me?
Because now you can bring it.
Because now the 3 can go whoop right out front. Okay? Now, how am I going to write the x to the 5th?
X to the
X to the 3rd times x squared.
X to the 3rd times x squared, right? Because I'm going to have to take that and put them back together anyway, so why not just leave it? Does that make sense?
Yeah.
So now I'm going to go whoop, and I'm going to go whoop, and I'm going to go, what's out front now?
3.
3, x, and then I've got the cube root of
5 times x squared.
Dumb.
It looks complicated.
What'd you say, Hadley?
I said it looks complicated and then it's not that bad.
Well, that's what I try to do is take things that look complicated and make them seem not so
I
complicated.
appreciate it.
I do what I do, you know. I'll be here all year. Yo,
Do you leave that index 3 on the answer?
Ah, great point. Do I leave that 3 there?
Yes.
Yes, because if it wasn't there, this problem would have been
That would have been a different answer.
different answer. Does that make sense? Got to have it. And you'll be surprised at how many kids will miss that on the test. It's kind of like labeling. You go back and watch my video. When I taught that, I remember specifically saying we always label that point, right? Yeah, when we took the test, about half of you said, well, it didn't explicitly tell me that because I already told you that in class. You didn't, so you lost 4. Nobody knows what I'm talking about? Yeah, I know like half of you did that, right? So, yeah, it's important. You got to have that number there, because if not, it's something else. Good question. Anybody else?
And you just write it in between those 2 lines.
Yeah, it goes right in that. It looks like this. That's the index number right there. Okay? That's actually a really good one. Yeah, because mine usually suck. So they never have this little doohickey right there. Okay. Now, let's say, okay, now, adding, let's do this. This adding and subtracting radicals. Well, dude, don't do that. Oh man, it's like when your parents ask you to do the dishes after Sunday dinner. It's like, oh, it's the end of the world. Bunch of girls, man. Now, so what if I did this? So if I went 3x plus 2x plus 7y, what would you do? Yeah, and to be a like term, it's only going to be the what? Yeah, so I'm going to get radicals behave the same. Okay? So if I got 3 roots of 2 plus 7 roots of 2, I'm going to get 10 roots of 2. Okay? If I've got 4 roots of 5 plus 5 roots of 4, that's not a good one. Don't put a 4 there. Put a 3. Because you would never leave a 4 as the square root of 4. Does anybody know why? Yeah, because I can simplify that. It's like a fraction. But let's say I did that. Can I do that? No, because these are not, for lack of a better term, it's like they're not like what? Not like bases, like terms, right? Here, they were both x's. They are like terms. I can add them together, right? Here, they are like terms. I can add them together. Here, they're no longer like terms. I cannot add them together. The same thing happens, this goes back to your question. If I had 7 square roots of 2 plus 5 cube roots of 2, can I add them together? No, because that's a square root of 2 and that's a cube root of 2, and they are different. Does that make sense? Alrighty, now, let's say I did this. Let's say I went, 7 roots of 5 plus 9 roots of 3 minus 4 roots of 5 plus 3 roots of 27. Let's say I did that. Okay? Now, right off the bat, what do you see? Yo, Hadley.
That one can be reduced.
This one can be reduced. Now, I'm going to be honest, that's not what people see first. I'm impressed that you saw that first. But you're like rare.
My bad.
Going back to that special probably.
Yeah.
We talked about earlier. So, Inglesy. BAM! Because Inglesy's back there.
Yeah.
Yeah, what do you got?
It's the 7 roots of 5.
Yeah, I got roots of 5 and I got roots of 5, which is going to give me 3 roots of 5, right? Because it's just like variables. And I got plus 9 roots of 3 plus 3 roots of 27. And I cannot tell you how many kids will be going, yeah, that's right, woo, yay me. And then they'll get it wrong, right? Because, unlike Special Hadley, they did not see that that is something I can simplify, right? So what is this going to turn into?
3.
Now, so pay attention here. When I do this, this is, and I'm going to take a shortcut here. I know that that's going to be 3 squared and 3, right? And that 3 is going to be whooped out, right? When I whoop that out front, if there's something already out there, what does it do? Multiplies. So So I've really got 3 roots of 5 plus 9 roots of 3. Now, it's really important that we say this correctly. Okay, sorry, Barker, I'm going to pick on you. Did you hear what you said? You said 9 to the root of 3, which to me would conjure up it's a what? Exponent. It's just 9 roots of 3. Do we all understand how that little change, if someone wasn't paying attention, they heard that. Do you see how that could screw them up? Yeah. So I'm going to end up with 9 roots of 3, correct? Now these are like terms, and I'm going to get what? Now you heard it, didn't you? See, now you heard it. It is 3 roots of 5 plus 18 roots of 3, just like that. Flinders.
That's probably a dumb question. But
No, they're never mind. They got covered up by the amigos back there. But I used to have a really good list of 10 stupid questions to ask. And I'm not even any more sure that they're even dumb nowadays. It's like one is, hey, can we go outside for class? Well, traditionally that would be a hard and fast no, but like when it's warm, I've seen all kinds of classes. It'd be hard to do math outside. But, like sign language, they can go outside, So anyway, what do you got for me, Flinders?
well, like fractions, you know how like if it's like 3 over 5 and then like 9 over 3 to combine them, you like put a common denominator. Can you do that with this or no?
No. But that was a great idea, but no, you can't.
Okay.
Okay, cannot common denominator. What's there is all you can use. No, that's a good question. Yeah.
So you can still combine like terms if there's a variable in the radicand, right?
Oh, yeah. Yes, you're saying if I had like 3 roots of x plus 6 roots of x?
Yeah.
Yeah. It's just going to be 9 roots of x. Doesn't matter. Yeah. Okay. Is that making any sense? What was that?
It's a joke on TikTok.
It's a what?
You went yeah, and there's a singer that always challenges people. He goes yeah.
You can search
Like
it up
in a
if you
single
want. Search up
Like that TikTok that was going to be banned, but then all of a sudden they got not banned.
Yep.
Do you guys know what I'm talking about?
Yeah.
Okay.
Ran this last Sunday.
You, name?
Matthias Horton,
Oh, Matthias, gotcha.
do you care when we simplify the equation, like the percentages? Do you want us to do it at the beginning or near the end?
What do you mean?
Like, do you want us to turn it?
Like the 3 into 9 to 27. He's asking if you do that.
I don't care when. No, yeah. Whatever you want to do that works for you, as long as it works every time, as long as you can get to, here was where we got, right?
Yeah.
Yeah. If you would have done that up here, you would have saved yourself a step, which would have saved yourself a line on the sheet of paper. I'm all for that. Yeah. Was there a hand over here? Yo. Wait a minute. So it's Dixon. That's Herb, D. You're a D or an E, I know that. Drake. Ian. Ian?
Yeah.
Yeah. Okay.
So is there a standard form for this?
Okay, that's a great question. Great question. Anybody know what it is?
I have no clue.
Nope.
Isn't it the indexes are in order, so like the highest index is at the beginning, and then it goes down?
Backwards.
Oh,
The lowest index, because when because what you guys, well, so what we're gonna do is we'll do this. Like if I have the square root of x, that is really. Does anybody know how to rewrite that in what's called exponential? Right now it's called radical form, and you will learn how to write it in exponential form, which means I'm going to write it as an exponent.
x to 1/2.
It's x to the 1/2, right? So now watch. So if I had the cube root of x, that would be x to the 1/3, which is actually less than 1/2, right? So here's an interesting story. Back before any of you were born, so yeah, a few years ago. Well, it's more like 30 now. So Burger King came out with a new burger, and they called it the third pound special, right? And it crashed and burned famously. Does anybody know why? No, because people said, well, why would I buy a third pound if I can buy a quarter pound? 3 is smaller than 4. And they thought the burger was actually getting, no, they thought it was getting smaller when in reality it was getting bigger. Yeah. Because the smaller numbers in the denominator. Yeah, they didn't get it, and they pulled it after like 6 months. Yeah, it was kind of funny. But it really was a factor of the fact that your average human didn't understand fractions. Which is why, have I ever told you guys about fractions?
No.
Fractions are your friend. They are. But they're that one obnoxious friend you have that you can only hang out with so much. Now I need you to visualize for a minute your group of friends. And I need you to determine who that is. Now, if you are having, a lot of you can name it instantly. If you can't, it's you. So, I'm just saying. Yeah. It's, oh, you see, he's like throwing somebody right under the bus right now. Remember, this is online.
You would agree too.
Oh, okay. Just remember, what's said in here goes online. So.
I thought it was great.
What happened?
Well, see, you don't understand.
Posted on the internet.
We're videoing.
My wife won't get online and look unless one of these two go and say, hey, you probably ought to go check out yesterday's video. But they both know better because I know the guy that gives out grades.
Yeah.
See? Alrighty, now, that's like addition, subtraction, stuff like that. Now, everything changes when you go multiplication. Okay, so now we are going to multiply radicals. Dude, why are you being such a whiner today? Katie. Your smallest index would be in standard form, yeah. I'm going to be honest, I don't know that I would mark it wrong right now for that. But yeah, it would be a good habit to have. What's the matter? Was there a question?
I just forgot what the index was.
A little number out, right?
Right.
I put the circle and I wrote index. Okay, just
Perfect with the perfect.
that was a good one. It was. You got to admit that was a good one. Alrighty, now multiplying. So, if I have the square root of 5 and I times it by the square root of 12, what am I going to get? I'm going to get the square root of 60, right? Now, what are the rules to multiply radicals? Anybody know? There's only one. Yo, Ian.
They have to have the same index?
Must be the same index. Must be the same. How did you know that?
Ian, you're so
Ian's
smart.
big.
You're just smart.
Ian's really smart.
Good job, Ian. Ghost fist bump. Bam. Alrighty. That's it. Now, what's going to happen if I leave that as my answer?
You're gonna get it wrong.
Why am I going to get it wrong?
Because it's not simplified.
Yeah, I didn't whoop it, right? So I had to go whoop. Now, you're all making fun of me, but I'm doing that for a reason. I assure you, the next time you see a radical, the first thing that's going to come to your mind is what?
I like it.
Yeah, so, what is the square root of 60 going to give me?
5 and 12.
Now, listen to me. You guys need to learn easy ways to do this. What I mean by easy way is see things that work. This is what I would do. I would do 4 and 15. Anybody know why I would have done 4 and 15? And I'm going to get what?
2 squared.
2 roots of 15, right?
Dang.
Bam! I'll be here all year just going woo. Okay? Now what if I did this though? Let's say I had the square root of 7 and I got 3 plus the square root of 5.
So
Okay?
I know how to do.
So now, rules don't change. I'm going to distribute, right? So I'm going to go there and I'm going to go there. Remember what I said radicals behaved kind of like? Kind of like variables, right? Well, pretend. What'd you say?
Oh, President was looking at me. I said that you did say that they can be like terms too,
They can be, you're right. But that's only when I'm doing what?
when you're adding.
Adding and subtracting. Good job, Dixon. Don't give her the look, Barker. Man, I'm watching you. teenagers. So how is this going to times that when that doesn't have a radical on it? Yeah, it just goes out front, and it's just going to end up with 3 roots of 7.
The index doesn't do anything.
Index doesn't matter. Nope. Plus, now I'm just going to go the
Root of 35. How do you say that?
root of 35, square root of 35. Now, right now, a lot of people are thinking, yeah, that wasn't so bad. But I got to remember to try and whoop it, right? So before you're done, always look at these and say, can I whoop them? Can I pull something out? If I can't, because when I factor tree that, I get 7 and 5, and they're both what? Both primes. I can't whoop it. Slap my circle around it, and right, done. Okay? Now, let's say I did 3 plus the square root of 11. No, they're like ones off the assignment, though. So, yeah, when I look over here, I look and say, oh, I better do that kind of problem because I'm not sure they'll do that.
Foils and square roots.
Would you like?
No, I'm good.
Okay, well, I just steal my thunder. Jeez. Let's go 2 minus the square root of 5. Okay, now, the minute I see this, I do need to think FOIL, right? It doesn't change, they're just changing the numbers, okay? So I'm going to go just like I would have from last test, right? 3 times 2 is 6. 3 times the negative square root of 5 is going to be?
Negative 3 square roots of 5.
Wow, that's a good job. It's like choir class. Then I'm going to get?
2 roots of 7. And square root of 55.
Minus square root of 55, right? Now, just like when we fooled before, what do I always got to remember to try and do here? Combine like terms. Little chicken, lettuce, and tomato. Roots of 5 and roots of 11 and roots of 55. None of them are like Dixon?
What? Like terms.
Like terms, so I can't do what? See how I knew that would just, you're like, BAM! That's right. Okay? So what would I do here?
You reduce the. Oh wait, no, you can't.
Yeah. See how I chose good numbers here? Yeah, because it's kind of big, huh? But at prime factorization's 5 and 11, it doesn't do me any good. So I would just be like, bam, D-U-N, done.
Would the 6 technically go in front of or behind when you're putting it in standard form? Does that make sense?
Negative.
Like what order would you put the?
Okay, so technically, and I'm going to be honest, I've been teaching for this is year 23, which basically is saying I'm really good at this. I've never thought about that. You're right. Does anybody know what would happen here?
Well, is it?
Why? Do you know? Did somebody just get an ESPN update?
It looks better.
Is that what that sound? Yeah, was that?
Yeah.
Who was that? Wow, I'm impressed. It wasn't a boy. Yeah, good job.
I could
Now-
out baseball any.
Now turn it off.
I
Oh, okay. Did you say you could out baseball any of us?
I know more about baseball than him. I think I could beat him too.
Who?
Peyton?
I think I might.
I mean.
Is that Whitley's little brother?
Yes.
Yeah. Is he a baseball guy?
Yes.
Oh, yeah?
Have you met Peyton?
Thanks.
What is his hat
Yeah,
like?
it's more impressive than
Don't
Around
I-
your head.
Doesn't he sit right back there
No.
in my next class?
I don't know.
He's on your.
Not in.
He's on your. We're not in
your what? I'm pretty sure he's in my 5th period, ain't he?
We don't know. We're not in your.
Well, don't you have friends and know their schedules? Yeah, he sits right there. I knew it. See, I called that. He sits right there. I'll have to hit him up. I was a baseball guy back in the day. Alrighty, so technically, you want to old Becca Craig it, okay? Why? Do you know why though? Because if you were to think about it that way, now in reality it doesn't matter because none of these have any what? No, there's no. Okay. No, there's no variables in here. So really, I only got to worry about standard form if there were variables in here. But if there was, This would have been 6x to the 0, because that x to the 0 is 1. 1 times 6 is 6. So it probably would have gone to the end. But there's no variables in here, so you don't have to worry about it. If there was, then yes, I would worry about it. Okay? Alrighty, now, what if I did, here's a good one. Let's say I did this, okay? Let's say I did 3 square roots of 12 times 6 square roots of 8. Okay?
I feel like we'll be able to do that. Because
That's a good feeling.
they look like they can go. David, that was all you.
You add
Nope.
Did you simplify it?
Katie?
I was just gonna say I'd reduce the. You can
Okay, now. Okay, so that's why I picked this problem. Okay? There's 2 ways to do this. Okay? One is to times it and then whoop it. The other one is to whoop it and then times it. The only drawback to whooping it and then timesing it is sometimes you have to whoop it twice. Okay? I'm not sure it qualifies as gross. Maybe challenging, but not gross. Gross is a teenage boy. That's what gross is. Been there, done that. Own multiple t-shirts. Okay? So, let's look at this. If I did not whoop it first, what would I end up with? 18 roots of 96. Then I whoop this, right? But let's say I go Katie's route and I whoop it first, right? What would this give me? Can anybody just do that in their head?
9 square root 3.
Okay? No.
So,
It's 6.
Okay, now remember, when I whoop that out, it's just timesing. It's not going to the exponent, right, David? So it would have been 6 square roots of 3, because I pulled that 2 out, right? 2 times 3 is 6. Times what's this? 12 roots of 2. Now, in this situation, I'm good, and I'm going to end up with what? 72 square roots of 6, right? Now, let's go back to what we had before. 18 roots of 96, right? 18 roots of 96. Now I just got to factor 96. And the only reason this might be a little challenging is that sometimes that radicand in there might get quite what? Big, then I might have to be a big old factor tree, right? Well, again, are there any easy ways to factor 96?
4 times
9 and 12, that's what I... No, 8 and 12. 30 what? 32 and 2.
4 and 16.
Now. No, 4 and 16 ain't it.
4 and
I know it's 6 and something, isn't it?
6 and 16.
6 and 16. Now, why would I have... Hey, use the tools you got, right? Now, why would I have chosen 6 and 16 at first if I would have saw that? Well, because I know 16 already gives me 4 squared, doesn't it? So I know that 4 is going to do what? It's going to whoop out when I take 4 times 18. Money says that is 72 roots of 6. Same thing, just done a different way. More than one way to skin a cat. Yo, Weston.
Couldn't you then factor down 6?
Yeah.
I can, but 6 gives me 2 and 3, and they're both what? Prime. So does anything else come out? No, if nothing comes out, leave them together. But that's a great question, Weston.
So you don't have to keep, because you can keep going on that 4 too. You don't have
I
to.
can, but once I can whoop it, don't waste your time. I'm done. Bam! Let's pull it out, because then I don't have to do any more work. And I'm a corner cutter. I was a teenager once. I know all the little shortcut tricks, which is why when kids try to cheat in my class, I just laugh at them, and I'm like, dude, I ain't that old. Been there, done that. Yeah. But didn't get caught. I would. That's a lie. I would have never, ever cheated in school. You guys. I'm just gonna ignore that. I don't know. That's about it. Questions? You sucked? Did you say I sucked?
I said, can we start?
Can you start?
Yeah.
Well, I need to see if there are any questions out there.
Nope.
You really thought he said you suck?
Somebody else had to have heard that.
I heard it.
Okay, see? See? But then I thought,
What would you have done though?
I know where he lives. And I know his mom and his dad and all his sisters, so. Dude, I have everyone's address.
What's up? What are you, Batman?
I'm the teacher.
You have Trump's address?
What?
You have everyone's or just the
Well, all my students. Plus, I live in the area. It's not like I live somewhere else. You know. Yo! Shh. Make sure you fill out the form. All right, I guess the answer to Barker's question is yes. Let's do it. In case you didn't know, he asked if you could get started. Not that I suck. Because that would end poorly.
No, because you're the greatest teacher of all time.
He is.
I'm just That's what you told me.
I did?
Yeah.
I could have said that. Master, Supreme Overlord. Get it right. Yo.
So I pulled out this, and this is an example, like one of the ones I was talking about. So you would.
2x minus 5 times 2x minus 5 foiling something.
Okay, so you do have to foil
Yep,
it to
yep,
every.
yep. No, you got to write it twice and then foil it. You can't distribute because of that minus sign. I got it different.
But if there was one.
Then I could just foil it. Yes. Yes.
Is 2, 2, and 2, 3 pre-score did tonight?
Yes. I believe that's up. Check it. Is 2, 2, 2, 3 pre-score up?
It's due tonight.
Yeah. God, but see, yeah, it is.
So we need to have the. 1 second. The index and all our answers, right?
No, only if it's something besides a 2. And there's a couple on there that are 3s just to see if you're paying attention. Right? Are there just like a couple of 3s as index numbers? I'm pretty sure. Who has it up? Is there a couple of 3s? Yeah, just to see if you're paying attention. That's the only time you have to have an index number is when it's not a 2. Okay? Good question. All right, let's do it.